Hello viewers, in today's session we are going to discuss another important and conceptual problem from definite integrals. And in this session we'll solve this integral where we have the limits from minus pi by 2 to pi by 2, and the integrand is absolute value of cosine x, right? So this problem is going to be a very important and conceptual problem, and here we'll make use of one important property of definite integrals along with the definition of mod function, right? And we'll also make use of the sign convention of trigonometric functions in four quadrants, right? So let us start. So let us first call this integral as I, and here our integrand is mod of cosine x. So let us take f of x is equal to mod cos of x. Now here before moving further, let us see an important property of definite integrals, and the property it goes like this. If we have the integral from minus a to a, and here we have f of x dx, and if this function f of x is an even function, then the value of this integral is equal to 2 times the integral from 0 to a f of x dx, right? So whenever our integrand, that is f of x, is an even function, then the integral from minus a to a f of x dx is equal to 2 times the integral from 0 to a f of x dx. Now we know that a function f of x is said to be an even function if f of minus x is equal to f of x, right? So here f of x is equal to mod of cosine x. So if we replace x by minus x, then we have mod of cos of minus x. Now from trigonometry, we know that cos of minus theta is equal to cosine theta. So here we have mod of simply cos of x, because cos of minus x is equal to cos of x. And here a mod of cos x is equal to f of x, right? So we can see that f of minus x is equal to f of x. So we can claim that the integrand, that is the mod of cos of x, is an even function, right? So we can now apply this property to this integral. So now we can write this integral I as 2 times the integral from 0 to pi by 2, and here we have mod of cos of x dx. So if we compare this integral with this one, then the value of a is equal to pi by 2. So now we have to solve this integral, right? And here the limits of integration are from 0 to pi by 2. So let us see the sign convention of trigonometric functions in four quadrants. So here we have the quadrants. This is 0, this is pi by 2, this is pi, this is 3 pi by 2, and this is 2 pi. So this is first quadrant, this is second, this is third, and this is fourth, right? And we know that here the limits of integration are from 0 to pi by 2. So we have to restrict ourselves to the first quadrant only, and in the first quadrant all the trigonometric functions are positive, right? So here cosine x is positive. Now let us see the definition of mod function. So mod of p is defined as positive p whenever p is greater than 0, mod of p is 0 whenever p is equal to 0, and mod of p is negative p when p is less than 0. So now let us apply the definition of mod function to a mod of cos x, right? So mod of cos x is equal to a positive cosine x when cos x is greater than 0, right? And we know that cosine x is positive, that is cos of x is greater than 0 for all x belonging to the first quadrant, right? So here we'll replace a mod of cos x by positive cos x. So now our integral I, it takes the form 2 times 0 to pi by 2, and here we have positive cos x and dx. So now we have a simple integral, and here the integral of cosine x is simply sine x, and the limits of integration are from 0 to pi by 2. So now let us substitute the limits and we'll take the difference. So we have sine pi by 2 minus sine of 0, and we have sine pi by 2, that is sine 90 degrees is 1, and sine 0 is 0. So we have 2 times 1, that is equal to 2, right? So viewers, the value of this integral is equal to 2.